In this video, we will be looking into deploying Backstage, how to deploy Backstage in your uh, production and development environments. So Backstage provides tooling to build Docker images that can be deployed with or without Docker or many different on many different infrastructures. So the best way to deploy Backstage is in the same way you deploy any other software at your organization. So so in this video, we'll show you how to the common examples that may be useful when deploying Backstage for the first time or for those without establishing deployment practices. So the easiest way to explore Backstage is to visit the live demo site. So, so we usually deploy software generally by building a Docker image, storing the Docker image on a container registry, and then referencing the image in a Kubernetes deployment YAML, and then applying that deployment to a Kubernetes cluster. So this method is covered in this tutorial. So deploying, building a Docker image and deploying with Kubernetes, we'll explain in a bit. Uh, there are many ways to deploy Backstage, but you can find more examples in the community contributed guides in the documentation if you want to. So if you need to run Backstage behind a corporate proxy, we can you can do the uh, research on contributed guide. That guide will help. So, so coming to scaling a Backstage deployment, how do we do that? There are several different methods for scaling Backstage deployments. So the most straightforward one is to simply deploy multiple identical instances and distributing incoming requests across them. So the one requirement for this to work is that all instances need to share the same external resources, such as the database and optional caching or search services. So the Backstage backend plugins will coordinate through the database to share state and coordinate work. So another method for scaling Backstage deployments is to break apart the backend into multiple different services, each running a different set of plugins. So this is more advanced approach and requires you to be able to route requests to the appropriate backends based on the plugin ID. So both for ingress, but also internal traffic between Backstage backends, which is done by creating a custom implementation of the discovery service interface. So you can also refer to the documentation for more details on how to separate your deployment into multiple backend instances. So lastly, you can also replicate the Backstage deployments across multiple regions. And this is not a pattern that there is built-in support for the typical user. So and typically only this makes sense only to do for individual backend plugins. Okay, so coming to building a Docker image, let's see how this is done. So in this section, we will describe how to build a Backstage app into a deployable Docker image. So it is split into three sections. So first one covers the host build approach, and which is recommended due to its speed and more efficient and often simpler caching. So the second section covers a full multi-stage Docker build, and the last section covers how to deploy the front end and back end as separate images. So the prerequisites for this tutorial is that we assume that you have a basic understanding of Docker and how it works. And if you are new to Docker, you can start with the Docker overview guide in the Docker website. So you'll also want to complete the following prerequisites. So you need to have created an app following the getting started tutorial. So introduction of Backstage and creating an app with Backstage. So, and the second requirement is that you need to set up an auth provider. So the authentication setup is helpful, is a good starting point for this. And the default guest auth provider is not intended for use in containerized environments. So a Postgres database setup should be there that you are able to connect to. The database guide can help you in that. Moving forward, without addressing these prerequisites, is very likely to cause undesirable results. The most common being not having a proper auth provider setup as the default guest auth provider is not intended for use in containerized environments. So, first thing that we'll see now is the host build approach. So, let's say, so in this section, we will describe how to build a Docker image from a Backstage repo with most of the build happening outside of Docker. So, this is almost always the faster approach as the build steps tend to execute faster and it's possible to have more efficient caching of dependencies on the host. So where a single change won't burst the entire cache. So the required steps in the host build are to install dependencies with yarn install. So let's move to my Backstage and do yarn install. And we'll use immutable flag. So the required steps in the host build are to install dependencies with yarn install and generate type definitions using yarn TSC, which is TypeScript compile, and build the backend package with yarn build backend. So we have installed the dependencies. So let's do yarn TSC TypeScript compile. And there are some issues that we need to fix. We can comment out this part and do it one more time. And this is we need to remove unused imports. And there is one more. All right, we are done with compilation. Now let's build the backend. Yarn build backend. Now this is built, and so once the host build is complete, we are ready to build our image. So this Docker file is included when creating a new app with Backstage Create app. So you can see the details of multi-stage build and host build also here. So for more details on how the backend bundle command and the skeleton tortoises file works, you can see the backend bundle command documentation. So the Docker file is located at packages, backend, and Docker file. So but needs to be executed with the root of the repo as the build context in order to get access to the root yarn log file and package.json file, along with any other files that might be needed, such as npm-rc and so on. So the backstage create app command adds the following docker ignore, this docker ignore, in the root of the repo to speed up the build by reducing the build context size. So you can see the changes here. So with the project built and the Docker ignore and Docker file in place, we are now ready to build the final image from the root of the repo. So from the root of the repo, let's execute the build with Docker image build and so packages backend Docker file, and we'll give a tag as backstage. We need to start Docker. Let me start Docker. Let's run this Docker build. All the build process is done. To try out the image locally, you can run the command docker run -ip -b 7007 to 7007, and then the image tag. So you should then start to get logs in your terminal, and that's failing. It's failing to connect to the Postgres database. Let's start the Postgres also. So I'm starting the Postgres server. Let's run it one more time now. And still the same problem, but I think and if you see the config, let's see. We have this template, and let's see. Host and username and password. This is not running on host network. So if you have the Postgres running in the same host network, it will work. So for now, let's skip that part now. So coming to the multi-stage build, so the Docker ignore is different in this setup. So go on for the more details. This section describes how to set up a multi-stage Docker build that builds the entire project within Docker. So this is typically slower than a host build, but is sometimes desired because Docker in Docker is not available in the build environment or due to other requirements. So the build is split into three different stages, where the first stage finds all the package.json files that are relevant for the initial install step, enabling us to cache the initial yarn install that installs all dependencies. The second stage executes the build itself and is similar to the steps that we executed on the host in the host build. So the third and final stage is then packages packages it all together into the final image and is similar to the Docker file of the host build. So let's do that here. So let's create a file for multi-stage build, Docker file. So the first thing is going to be, so we need to declare the initial image. So this is going to be the image. We will define work directory as /app. We will copy backstage.json, package.json, and yarn log.json to the current work directory. I think we need to put this inside my backstage. We'll move this file to here. Okay, next thing is that we will copy yarn cache into yarn cache and copy yarn rcml into the current directory. And then we will copy packages folder into packages folder again. And then copy plugins into plugins. Then we will run the find command to get all the package.json files. So the command is looks like this: package.json, and we will delete all those. And the second step, this is stage 2. So if we look at this, this is stage 1. That says this is like creating a skeleton, create yarn install skeleton. And the second step, stage 2, is that install the dependencies and build the packages. So for this, we need to use the same image, build step. So we will define an environment variable for Python. So the next step is to mount, install isolated VM dependencies. These are needed by the Backstage plugin scaffolder backend. So let's do that. Let's mount var cache. Var lib apt sharing. and then we will do apt get update, and then we'll do apt get install. We'll install Python 3, C++, C++, GNU, C++, builder, compiler, and build essentials, and then let's remove the cache to clean up the space. So then we will need to install SQLite 3 dependencies. You can skip this step if you don't use SQLite in the image. So in which case, we should also move a better SQLite to dev dependencies in package.json. So, but for now, let's assume that we have SQLite. So this same, and then we'll remove package lists. So next step is to choose the user as node and change the work directory to app, and then copy from packages. This is the initial skeleton that we built. We will change the ownership and copy to the current workspace. And then we will run yarn install again. For this also we need to do cache mount, and then do yarn install immutable. Then we will do copy the all the files, and we'll change the ownership to node and run TypeScript compile, and then run build. After that, we will do create a distribution directory, and we will compress this file into skeleton tar gz, and then we'll create one more tar file where bundle, and that's about the second step, the build process and packaging. So the stage three is to build the actual backend image and install production dependencies. So let's build stage three, build the actual backend image and install production dependencies. So for this one, we'll also use the same bookworm image. And now we need to set the env of Python to Python 3. And then we need to install isolated VM dependencies. So same process. And then apt-get install. Python 3, C++, build essential. And then we'll remove the listings, package lists. And then we will do install SQLite 3 dependencies like this, same process. Let's copy this one and paste it right here. Instead of this, we will install SQLite 3. Yeah. So that's about the package installations. And then we will now switch the user to Node. And let's make the work directory as app. So this should create the app directory as node user. So if it is instead created as root, then the tar command to extract will fail. Can't create directory packages, permission denied error will come. So if this occurs, then ensure build kit is enabled. Docker build kit should be enabled. So the app directory is correctly created as node user. So now copy all the install dependencies from build stage and context. So let's do that from build stage and change the ownership to node and node. So app yarn to current yarn. And again, one more from app yarn rc YAML to current folder as well. Similarly, we will need backstage.json to the current directory. And one more is yarn log file. And then the package JSON, and this should be moved into specific location. And one more file we need to copy is app packages backend test skeleton into the current directory. And the skeleton bundle only includes package.json files. So if your app has plugins that define a bin export, the bin files need to be copied as well to be linked to in the node modules bin during the app yarn install process. So next process is to run yarn workspaces command. So for that also we're going to use this caching, and we're going to issue yarn workspace focus all to production and remove this. Clean the yarn cache. Then you can copy the build packages from the build stage into the current directory. So copy from build, change the ownership to node user. From the distribution bundle, we will copy all the files into the current directory, and then copy any other files that we need at the runtime. So let's do that. App configs is required. This will include the examples. If you don't need these, simply remove this line, the next line. So we will just use the examples here. So this the next line will switch many Node.js dependencies to production mode. So let's change the node env to production. So let's do node options as no node snapshots. So basically this disables node snapshot for node 20 to work with the scaffolder. And the main run command should be like this: node packages backend config app config.yaml, and then config app config at production.yaml, and it overrides both. So note that a newly created Backstage app will typically not have a plugins folder, so you will want to comment that line out. So this build also does not work in the main repo since the Backstage CLI, which is used for the build, doesn't end up being properly installed. So to speed up the build when not running in a fresh clone of the repo, you should set up a Docker ignore file. So this one is different than the post build one. So let's use a Docker ignore file that we will use. So a Docker ignore file will be like this. It will have test types, node modules, packages, star, test packages, star, node modules, packages, sorry, plugins, star distribution files, plugins, star, node modules, and then star.local.payment. So this is the typical Docker ignore file for the multi-stage build process. Once you have added both the Docker file and Docker ignore to the root of your project, so you can run the following commands: Docker image build backstage, and this is for building. And to try out image locally, you can run this other command: Docker run it, and then backstage. So you should then start to get logs in your terminal, and then you can open your browser at localhost 7007. Yeah, that's about the multi-stage build. So the next thing is the separate front end. So in this multi-stage and host builds, we are combining front end and back end into one single image. So if you want to separate out front end and back end, and this is an optional step. So and you lose out on the features of Backstage plugin app backend plugin. So most notably, the front end configuration will no longer be injected by the backend. So you will instead need to use the correct configuration when building the front end bundle. So it is sometimes desirable to serve the front end separately from the backend, either from a separate image or, for example, a static file server serving provider. So the first step in doing so is to remove the app backend plugin from the backend package, which is done like this. So if you go to packages, backend source, app source plugins. So in the back packages, backend source and index file. So plugin app backend. Let's search for plugin app backend. We need to remove this line and remove the backstage plugin app backend and the app package dependency in the app. So in the package.json, we can search if app backend. It's not there. So if you don't remove the app package dependency, the app will still be built and bundled with the backend. So in order to do that, we should remove this dependency here. So once the app backend is removed from the backend, you can use your favorite static file serving method for serving the front end. An example of how to set up an Nginx image is can be referred in the contributions folder of the main repo of Backstage. So note that if you are building a separate Docker build of the front end, you probably need to adjust the Docker ignore appropriately. So most likely by making sure packages app test is not ignored. So if you face any problems, then you can check out the troubleshooting tips. So when building Docker images, you may run into problems from time to time. So there are two handy flags you can use to help. So if you enable progress plane option while building the images, this will give you a more verbose output and not fold the logs into sections. So this is very useful when having an error, but it just shows you the last command and possibly an exit code. Using this flag, you are more likely to see where the error actually is. And another option is no cache. So this will rebuild all the layers every time. This is helpful when you want to be sure that it's building from the scratch. So here is an example of this flags in use. So if you want to do that, Docker image build packages, backend, Docker file, tag, backstage. You can enable progress, full plain, then no cache. These two options will help you debug the build issues. So there are the Docker file mentioned above here is located in packages backend, is maintained by the maintainers of Backstage. However, there are also community contributed Docker file alternatives located in contrib Docker folder of the Backstage repo. So Docker files in contrib Docker folder are not maintained by the maintainers of Backstage and are not necessarily updated when the Docker file located in packages backend is updated. So, so a contributed Docker file exists within the directory of contrib Docker minimal hardened image, which uses the Wolfie base image to reduce vulnerabilities. So when this was contributed, this alternative Docker file reduced 98.2% of vulnerabilities in the built Backstage Docker image when compared with the image built from packages backend Docker file. To reduce maintenance, the digest of the image has been removed from the contrib Docker minimal hardened image slash Docker file. So a complete example with the digest would be something we can refer in the documentation, and it's suggested to update the from line in the Docker file to use the digest. Please do a Docker pull on the image to get the latest digest for the Wolfie image. So using the digest allows tools such as Dependabot or Runaway to know exactly which image digest is being utilized and allows you to pull requests to be triggered when a new digest is available. So it is suggested to set up Dependabot or Renovate on a similar tool or a similar tool to ensure the image is kept up to date so that vulnerability fixes that have been addressed are pulled into your repo frequently. And so the next step is to deploy using Kubernetes. We have seen so far building plain Docker files and running the Docker images. So now let's look into deploying with Kubernetes. So Kubernetes is a system for deploying, scaling, and managing containerized applications. So Backstage is designed to fit this model and run as a stateless application with a external Postgres database. So there are many different tools and patterns for Kubernetes clusters. So the best way to deploy to an existing Kubernetes setup is the same way you deploy everything else. So this section will cover basic Kubernetes definitions needed to get Backstage up and running in a typical cluster. So the object definitions might look familiar to you since the Backstage software catalog also uses the Kubernetes object format for its entity definitions. So to test locally, you need to have to test out these concepts locally. Actually, before deploying to your production Kubernetes cluster, first install kubectl, the Kubernetes command line tool. So next install minikube. This creates a single node Kubernetes cluster on your local machine. Let's see if I have this installed. Stay minikube, not there. All right, minikube is one utility you can use. So in order to use the minikube, you can in macOS you can install with brew install minikube and then do minikube start. So you can do that, and now you can run kubectl commands and have changes applied to the minikube cluster. You should be able to see the kube system Kubernetes pods running if you issue a command like this kubectl get pods -a. So when you're done with the tutorial, use minikube stop to halt the cluster and free up resources. So in order to create a namespace, first thing you need to do is uh, deployments in Kubernetes are commonly assigned to their own namespace to isolate services in a multi-tenant environment. So this can be done through kubectl directly with kubectl create namespace. Let's say Backstage. So alternatively, you can create and apply a namespace definition. Let's do that. So let's do a namespace.yaml. So for that, we need to define API version as v1, find as namespace, metadata, name Backstage. And then you can issue this manifest file. You can issue kubectl apply and serve it as namespace.yaml. So this will create a namespace. So next step is to create a Postgres database. So Backstage in production uses Postgres as a database. So isolate the database from Backstage app deployments. We can create a separate Kubernetes deployment for PostgreSQL. So let's create a PostgreSQL secret. Postgres secrets YAML. Let's say we'll issue v1 as the version and as secret. Let's give the name as Postgres secrets. Namespace is going to be Backstage. Type opaque data. So we will have Postgres username something, Postgres password something. So the data in Kubernetes secrets are base 64 encoded. So this too is 64-bit base 64 encoded. The values can be generated on the command line with simple commands like this. So let's say if you want to encode Backstage text into base 64, you can do it with this, and it will print something like this. Yeah. This will be the base 64 encoding of this Backstage text. So secrets are base 64 encoded, but not encrypted. But be sure to enable encryption at rest for the cluster. For storing secrets in Git, consider sealed secrets or other solutions. So the secret now can be applied to the Kubernetes cluster with this command, kubectl apply postgres secrets.yaml, and then we will create a Postgres persistent volume. PostgreSQL needs a persistent volume to store data. So we'll create one along with a persistent volume claim. In this case, we are claiming the whole volume, but claims can ask for only part of the volume as well. So let's create a file, Postgres storage.yaml. We do API version 1, persistent volume, the return name of the volume, Postgres storage, namespace, backstage, labels, local, specifications. We will say storage class name as manual, capacity. Let's give storage capacity as 2 GB. Access modes, read write ones, persistent volume, claim policy as retain, host path. Let's give it as dash mount data, and we will define volume claim here. So API version v1 will use kind as persistent volume claim. So the data metadata name Postgres storage name namespace backstage. Let's define the specs. Storage class name as manual. Access modes read write ones. Resources requests storage 2 GB. So you can claim less also. So this file contains definitions for two different kinds separately, separated by a line with a triple dash. This syntax is helpful if you want to consolidate related Kubernetes definitions in a single file and apply them all at once at the same time. So note that the volume type is local. So this creates a volume using local disk on Kubernetes nodes, more likely in a production scenario. So you'd want to use more highly available types of persistent volumes. So apply the storage volume and claim to the Kubernetes cluster with this command, kubectl apply. It is Postgres storage.yaml. This will create both uh, persistent volume and volume claim. So now let's create a Postgres deployment. I mean, now we can create a Kubernetes deployment descriptor for the PostgreSQL database deployment itself. Let's create a new file, postgres.yaml. Here we're going to use API version again as apps v1. This is the API for deployments. So find this deployment metadata. We use as name as Postgres namespace backstage. Let's use the specs as replicas 1. Selector match labels app Postgres. Then template, we'll define the template for the YAML deployment, metadata labels of Postgres. So we will define the specs for this deployment template. So it will have containers, only one container for now. That will have name as Postgres. Image is going to be Postgres. Let's say 13.2. I'll find image pull policy. If not present, and ports we will define as container port. 5432 is the default port. Environment can be got from the secret file. Secret reference, that's going to be Postgres secrets. And then env, public env variables. Here, name of the env is going to be Postgres host. Value is Postgres backstage. So this is the local resolution. And another variable, Postgres port. Value is going to be 5432. So, and we also need to mount the volume mounts in order to consume the data storage. Mount path is going to be varlib Postgres data, and name of this is going to be Postgres db subpath is data. Then comes the volumes definitions. Will be directly under container specification. So the volumes are going to be defined here. So only one volume we have for now, which is Postgres DB. And persistent volume claim is going to be claim name as Postgres storage claim. So that's about the Postgres deployment YAML. If you're not used to Kubernetes, this is a lot to take in. So we are describing a deployment, one or more instances of an application that we would like Kubernetes to know about in the metadata block. The spec block describes the desired state. Here we are requesting Kubernetes to create one replica running instance of Postgres, and to create the replica with the given pod template. So which again contains Kubernetes metadata and the desired state. The template spec shows one container created from the published Postgres 13.2 Alpine Docker image. So note the env from and secret ref references. This tells Kubernetes to fill environment variables in the container with values from the secret we created. We have also referenced the volume created for the deployment and given it to the mount path expected by Postgres. So apply this Postgres deployment to the Kubernetes cluster like this. kubectl apply -f ADS postgres.yaml, and then I can refer to the pods using this, list all the pods. So verify the deployment by connecting to the pod using this command kubectl exec namespace backstage postgres, whatever the uh, pod name will be, and you can use bin bash and check the Postgres instance. So you can create a Postgres service. Next, the database pod is running, but how does another pod connect to it? So Kubernetes pods are transient. They can be stopped, restarted, or created dynamically. Therefore, we don't want to try to connect to pods directly, but rather create a Kubernetes service. Service keeps track of pods and direct traffic to the right place. So we will see how to create the entire Kubernetes deployments in the next video.